G'day everyone, a quick video here on graphing complex subsets. So essentially what we're doing is taking a complex sort of equation and taking it to our Argand diagram, which is similar to our Cartesian, but that would be x and y. Because we're talking about imaginary or complex numbers, we've got real and imaginary to graph on here instead. Now with all of these three types, I really want to stress to you that if you understand what these are telling you, then they're very easy to do. If you don't, they're just a bunch of garbage, right? So let's look at the first one here. Let's see what this first one is telling us about. It's some complex number z. Okay, think a plus bi, some complex number somewhere around on here. Okay, now I'm just going to choose a point and say right here. Could be anywhere. Now this part here, I'm actually going to readjust that and I'm going to write minus 2 minus I. So I'm really just taking a -1 out front and making it a bracket. So now I've really got z minus, just write it above here, I've now really got that. And here's the key understanding, is what am I doing? I'm taking a complex number, any one, here it is, and I'm subtracting away another complex number. Okay? So by taking one number and subtracting away another, I'm really working out 2 points on the Argand diagram and the distance between them, or the amount of space between them. So this one, let's graph that one, 2 minus I. Well, that would be, I'm going to say 2's there, and I'm going to say minus I is there. So that's that point there. So this point here is 2 minus 1, or 2 minus I. This is the point that I'm, in this example, using as z, but really it's any point over the whole thing. So if I was to do that point minus that point, aren't I really just working out between the two? It's really distance down and distance across. Now then when I take the absolute value of that, aren't I then saying, well, tell me the distance between those 2 points? So 2 points, subtracting one away from the other means I'm working about distance, or sorry, the 2 points, and then I'm looking at the absolute value to get me this distance. And then what I'm saying, see how detailed this is, then I'm saying I only want to include those points that are less than or equal to 4 units. So this point becomes the center of a circle of radius 4. Any of the points in here, any complex point in there would fit this equation because the distance between 2 points would be less than or equal to 4. So this sort of equation sets up, it's a circle somewhere, and this part is telling you where the center of the circle is. Okay? This part is telling you the radius. This is telling you inside equal to or outside. This is telling you the center. And the solution, Z, the solution is any of those points in this circle. Right? As I say, it's very complex in here, but funny joke. But when you actually see what's going on, it's actually really easy to read. So I'm going to say we've done that one. This is what any of this style of them set up like. All right, let's get another Argand diagram here and let's do the next one. Have a look at that next one. This is kind of the easy one of them. Now we're talking about the argument of a complex number. Well, remember when you're in cis format, you've got r cis theta. Theta is the argument of it. So I'm saying that pi on 4 is less than or equal to the argument of z. Well, pi on 4 would be there. Okay, any of these points along here have an argument of pi on 4. They all have a different modulus, but an argument of pi on 4. Pi on 2 is greater than the argument of z. Well, pi on 2 would be right up there. So this set of arguments that are between here and here would be anything in there. Any complex number that falls in here will fit that right there. So as I say, this is the easy one. There's only the angles in there. Don't have to worry about distances or anything like that. It's just, here's my lower angle, here's my upper angle, and between the two is where the set of complex numbers that fit that are going to work. Easy one. That's not really a trouble for too many of you guys in spec. So now let's do the third one, which is also kind of a bit tricky. We've got to think about this one a bit. All right, so can you see how these are somewhat similar to what was going on here? But instead of a fixed number, and hence a radius, we've got two of them going on. All right, well, let's break it down. Notice I set this already up into one format. This one I would need to adjust. So I'm going to adjust this to Z minus, always Z minus, because I want to work the distance between 2 points. So therefore here I'd have to have -1 plus I. Oops. So that is the same as that. All right, hopefully I haven't made a mistake. I think I'm good there, yep. So I'm going to plot this point right here on my Argand diagram. -1 plus I. -1 plus I, I'll put that about there. Okay, so -1 plus I. This one, already set up in a neat format, is 2 minus I. 2 minus I, I'm going to put it there. So they're my 2 points in a similar way as to what I did here, but here I was a fixed figure, so it gave me a circle. Here I'm looking for the complex number that will mean that the distance from that complex number to this point is the same as from this complex number to this point. Now let's have a look at that. So replay that a little bit if you need to. If I've got these 2 points here, which are these two right here, and I want to choose some random complex numbers in here that make this equal, let's just pick a random one. I'll pick a point here. Now tell me, is the distance to that one and the distance to that one the same? No, this is clearly much longer. So that there is not a point that will fit this. So okay, let's get rid of that. Let's try another one. I'm going to choose a neat one that I know is going to work. I'm going to choose a point here. Now, as I said the other day, within the bounds of my drawing ability, which is not very good, let's assume that that distance is exactly the same as that distance. Well, therefore, if that was Z, then the difference between Z and there, the magnitude of that, will be equal to the distance between there, the magnitude of that. Okay? So this would be a point that would fit. Now what you find, if you keep going, this one will work, this one will work, this one will work. See how they're kind of, this one will work. And what you find is you have a line that goes between these 2 points where every single point on that line is equidistant from here and from here. Now you might go, oh gee, that's a bit crazy. Well, just think about it this way. If I took a line between those 2 points, and I found the midpoint of that line, well, that's the easiest point that's going to fit this, isn't it? And then this line is going to be a perpendicular bisector of that one. So this is going to be at 90 degrees. So a common question is to say, given the following, give the linear equation of the line that fits this kind of idea. And they're asking for the linear equation of this. How do we do it? Well, this point we can find by adding these 2 points and finding the midpoint. We can work out the gradient of that line. And remember your idea that m1 times m2 equals -1. So if I know this, the gradient of that one, then I can also figure out the gradient of that one. And this point right here, the midpoint of that one, is also a point on that line. And hence I can work out the equation of that line. Okay? That's kind of a lot there, but when you see a few questions, you'll get the hang of it. Kind of tricky, You see this format and you're thinking, that one's going to be a circle somewhere. Where was it? It was at -2 and I. Sorry, it was at 2 minus I there, and a radius of 4. That's what that one looked like. This one was the argument idea. So it was, here's pi on 4, I think, yep, and here's pi on 2. There's the area in between. That's what those look like. And then this one is this guy over here. All right, 3 kind of there. They're tricky to see, but if you can break down what they're telling you, they're really simple. Now, most of the time in tests and like, it's a sketch. It doesn't need to be perfectly accurate. It would be handy if you gave me this. I'd kind of go, do you really know or did you guess? I'd be putting on something like this and saying, oh, that's pi on 4. This I wouldn't so much worry because it's right up the axis, so I know that you had the right angle. Okay? Here I'd be plotting the points and showing what you're doing. Here I would be, I might just cheat a little bit, I would be doing something like this and saying r equals 4, and I would be noting that point to say, well, hey, look, I know where the centre is. It was at 2 minus 1. All right, so put a bit of information in there so we know what you're doing, but understand them. Understand them, they're kind of easy to do. Don't understand, you might as well just bypass the question. Hope this has helped. If you need more videos on this, please let me know. Catch you later.